We're now moving into our last topic for prologue. We're still in work guide number 1. Latitude and longitude are a coordinate system for us to find any place on Earth. We have created latitude and longitude to find and to represent things on a map. Latitude tends to be drawn east to west, and there are 3 major latitude lines, one of them being the equator, the North Pole, and the South Pole. The equator is 0 degrees, and the North and South Pole are respectively 90 degrees north and 90 degrees south. So one of the ways that I like to introduce the difference between latitude and longitude lines is that we could think of the grid system like a ladder, okay? And the steps on the ladder in blue are latitude. Think of it like you're crossing the T's. It also kind of rhymes. The steps on the ladder are latitude. So it's kind of similar. The long lines that hold the ladder together are longitude. So if we were to climb up the ladder steps, we would be increasing in latitude. If we were to maybe take a few steps on the ladder, this one being the equator at 0, maybe this first step would be 10 degrees north. We take a second step and maybe that's 20 degrees north, and so on until we get to 90 degrees north. The opposite would be true. If this is 0 degrees, the equator, we could be stepping down to 10 degrees south latitude. Another step down could be 20 degrees south latitude. And then these longitude lines we'll discuss in its own separate section. Before we move any further, I'd like you to try to answer, or to at least kind of explain on paper or in your Google Notes where everything goes on this map. Pause the video, give it a shot, try using page 4 in your reference tables, here on page 4, and there are some important latitude lines that you can utilize to help discuss what's on that map. So go ahead and pause the video, give it a shot. All right, so let's take a look. So here is the best way to label this map. And if you had struggled in labeling a map because it's hard to do that without having the physical paper on hand, here is an image that I have given you so you can see where everything is. If you want to take a screenshot, now is the time to take a screenshot, file it into a folder or elsewhere so you have it for safekeeping. You can label this as the latitude and longitude map and hemispheres. So we've got very important sections that I've labeled out, like the Tropic of Cancer, the Tropic of Capricorn, both being at 23.5 degrees, this one being north, this one being south. These are important because that's the tilt of the Earth. We've got our northern hemisphere, so everything above the equator. This blue arrow up, that's the northern hemisphere. This red arrow down to the bottom is the southern hemisphere. Then we also have superimposed the North Pole up here in red and the South Pole down here in blue at the very tips. Okay. Then we've got the Antarctic Circle and the Arctic Circle, both being 66.5 degrees, north being the Arctic Circle, south being the Antarctic Circle. All right, let's move on and be prepared to be on page 3 of your reference table. So, Polaris is the North Star. You may have heard of that before. It sits in the same spot all the time because our imaginary axis that runs through the planet that we rotate on is always pointed towards Polaris. So it becomes a really great reference item in the sky for navigation. So it doesn't move at all during the whole year. However, we are rotating, which means if you're to look up at the sky, Polaris would be like a dot in the sky, and if you viewed it long enough, it would look like, apparently, that the stars are going around Polaris. So we call these circumpolar stars because they circle around roughly. Now it's apparent motion, meaning they look like they are, but really we're the ones that are rotating. Also, the angle of Polaris with our horizon, which is the furthest place we can look, that angle is equal to your latitude on a map in the northern hemisphere only. So that means at the equator being 0 degrees latitude, Polaris is right on the horizon. If you are at the North Pole, it is directly overhead at the pole. Where we are, it's about 40 to 41 degrees above the horizon. So this is going to help us figure out where you are at night in terms of latitude. It was very helpful in the navigation in the past, and as always, we build on the shoulders of giants, so those that introduced this to us eventually gave way to modern day GPS. I also want to just make sure we highlight that Earth rotates at a rate of 15 degrees per hour. So I've defined, that's a degree symbol, HR for hour, here it is here. That's our rotation speed per hour. AKA, if you have 360 degrees in a circle and you divide it by 24, you get 15, 24 hours in a day. All right, so let's go to this map here. On page 3 of the reference tables, as you can see, like I said, there is no lines anywhere here. None whatsoever. Now, if you choose to open up my access point from the lab, which is a few slides ahead in the work guide, you will get a map that looks a lot like this, where I have drawn out the lines. It's gotten a little washed out because of the camera flash, but you can see the longitude lines are in blue, latitude lines are in red. I have labeled them with the correct degrees and compass symbol, and we will talk further about what this means during our lab. Okay? Now, for New York City, it's down here. It's actually labeled New York City, and you can see that there's a 41 degrees latitude line here. So the angle of Polaris is roughly 41 degrees above the horizon. Also, what I'd like to point out in this map, you have dots with names next to them. Those are the names of cities in New York State. We have little triangles, those are for mountains. We have very small italicized words that run along these odd-shaped lines, which are river symbols on our map with the name of the river. Okay? The other weird squiggly lines and hash lines and dots are related to this legend down here, which we will work with later in the year. For now, we just want to be able to identify what it is that's a city, what is a mountain, where are rivers, and maybe some information located in the lakes, like the elevation of the lakes, and maybe where our larger bodies of water are, like the ocean. Lake Ontario is also considered a large body of water. So keeping that in mind, that's going to be the main focus of this map for latitude and longitude. So what I'd like you to do next, pause the video, try out this diagram that's down here, which I'll share in a moment. Pause. And we're back. All right, so check your answers, see how you did. And I'll also answer this one down here. So take a moment, if you have to pause the video, check your answers. Now that you've checked your answers, this here explains a relationship in nature. Mainly being that as you increase in latitude towards the North or the South Pole, temperatures, average temperatures start to decrease. Where it gets colder at the poles with the increase in latitude. Notice I have two variables and I've linked them together in a relationship. So the temperature, that will increase. So I'm going to add the up arrow here. Temperature goes up with increased latitude values. All right, let's move on to longitude. So longitude are the long lines on the map. 0 is the prime meridian. And we go up to 180 degrees. So if this here is the prime meridian, half of this globe is 180 degrees because the circle is 360. Half of 360 is 180. So both sides are going to represent a hemisphere, the eastern hemisphere and the western hemisphere, respectively, away from the prime meridian. Make sure also that you always write in latitude, then longitude when you're giving me the coordinates. And you always put a comma in between when you write out your coordinates with the degree symbol and the compass unit. What I'd like you to do now is I'd like you to go to a guided practice, which is a couple pages down to here, and we're going to do these questions together very quickly. Then you're going to do your independent practice. You have an option to do a challenge sheet for extra credit, and also make sure that you're going to do the checkpoint after this before we move into time zones. Pause the video, give it a shot, and we'll be right back. Okay, we're back. So let's go over it together. What is the approximate altitude of Polaris when viewed from New York City? Well, that's the one we've been doing an example of, but let's review it rather quickly. So the reference tables, here is New York City. If you're using the access point version, I have a line, a red line for 41 degrees north that is very close to New York City. And the angle that Polaris makes with the horizon is equal to your latitude. So there it is, it's 41 degrees above the horizon. So you better choose choice 4. Down here, a similar structured question, except they're giving us a diagram. So base your answers to the question on the map below and your knowledge of Earth science. The map shows areas of daylight and darkness, daylight. On March 21st, there are 6 locations that are labeled on the map. 1, 2, 3, 4, 5, 6. If there happens to be regions this year, sometimes these maps are used for more than one question, but the one that applies to us is about Polaris. All right, so down here it says state the altitude of Polaris as seen by an observer, Slide Mountain. Boom. They're using a dot for Slide Mountain this time, which is a little tricky instead of a triangle, but it looks to me like it is lined up with 42 degrees. So we add a little 42 degrees there and you're good to go. This is the end of this video. Jump into independent practice, use the access points. If you want to challenge yourself, get some extra points, do that one. We'll figure out how to get you those answers for the answer key and then do the checkout. See you soon.